Good morning and good afternoon to everybody. Thanks for coming to this webinar. I'm happy to have you here in this webinar, which today I will talk about the latest release of PoolParty 5. And I'd also like to give you some ideas besides the product with regards to linked data applications, especially in the enterprise. Linked data in the enterprise has become a really broadly discussed topic in recent months, we've figured out, and so I'd like to talk a little bit about the experiences we've made. And yeah, it will take about 45 to 50 minutes, something like that. And at the end of the session, you're welcome to join in a discussion. If you want to stay with us until then, we'll open up the microphones and probably some questions will come up during this session. Okay, so give you a brief overview of the 5 chapters of this webinar. I'd like to start with a short introduction for those of you who are probably new to the topic of knowledge graphs and linked data, and give a quick idea what is really new about it, what's the difference to, let's say, traditional metadata management. Second chapter will be a quick overview of PoolParty Platform. Also for those who are probably not that familiar with this software, and I made a quick poll before we had the webinar, and I think about 50% have already worked with PoolParty, the other 50 hasn't, so it won't take too long, but to give you a quick overview of how PoolParty works in principle, to give you also some live demos of applications on top of that. That's part of 2. And number 3 then is really about one of the key principles of linked data and how to make use of PoolParty Semantic Suite, how to combine unstructured and structured data. So that's one of the really hot topics. You can make use of this technology. And number 4, of course, is one of the key elements of this webinar, which is PoolParty 5, what's new. So I will guide you through the main 5 new topics and show you what happened in the last few months here on our side and what's in the latest release. And last but not least, finally, I will introduce the linked data path, which is a kind of a small guideline how to introduce linked data in enterprises and in organizations in principle. It's kind of a collection of all the experiences we've made in the last few years and to figure out what could be the main obstacles to start with a linked data project. And so I will guide you through a couple of steps, and maybe that's a good start also for the discussion at the end of the session I've mentioned before. Okay, so just a quick overview of who is behind PoolParty. Semantic Web Company was founded back in 2001. We are a very specialized company, specialized on linked data technologies. In 2009, finally, we launched our product. We have a software engineering background, so the combination of those 2 topics brought us to the idea to bring a product to market which should support organizations with the creation of knowledge graphs in combination with text mining. Yeah, in the meantime, we are happy to have grown solid customer base and large partner network, mainly in the EU and in the US, but we also have customers in Australia and in Russia. So that's a short overview of our customers and partners, some of our customers on the left-hand side, selected partners in the middle, and they all have one goal in mind. And that's also what drives us here at Semantic Web Company. Make machines smart enough so that they can help us to find those needles in the haystack which are really relevant to us. Yeah, that's what we've been working on for quite a while now, and as you all know, I'm sure there's a large community doing working on the same efforts like we do, and it's a fantastic time to start with at the moment. It's really growing, the interest, and yeah, and I hope I will bring over also a little bit the enthusiasm we have here at Semantic Web Company. So let's start with chapter 1, the power of knowledge graphs. So that's really an outcome of a lot of, let's say, webinars and trainings we've made in the last years. How can we explain in 5 minutes what's really the difference between a traditional approach of tagging, of metadata management, and a graph-based approach? So let's do a quick example. Let's say there's a person, she would like to know all the, or see all the documents about European countries. And probably you've got already metadata on top of your media assets. Could be a document, could be a video, whatever. And as you can see here, that's not the perfect precondition to answer the question. So we need to introduce something new. We need to introduce the fact, okay, which documents are dealing with European countries. On the left-hand side, we probably would add a new tag, a new metadata field, and say, okay, here we have Europe introduced on the left-hand side. On the right-hand side, as you can see, we introduce a new concept, a new node somehow in a tree called Europe, which points to the already existing ones. And next step, of course, is it won't stay that simple. It would, all the information needs grow constantly. You want to ask more and more complex questions. So what do we have to do when the person wants to know everything about EU member countries? Sure, you can do it again in the traditional approach, add EU on top of those countries which belong to the European Union. On the right-hand side, you introduce a new graph, which is a, in that case, sub-concept of an already existing one called Europe, and a super concept, the parent concept of two others. So you let the knowledge graph grow on the right-hand side. On the left-hand side, you always have to introduce new tags. And that's a never-ending principle. So what happens here on the left-hand side? It's metadata per document. There's no little network effects here. There is virtually no reuse of metadata across the silos because they reside in the data silos. The data quality is also hard to measure. It's not standards-based most often, and it's not machine-readable necessarily. What's the matter with the graph-based approach? Here you have a principal other approach. It's not metadata per document anymore. It's really an additional layer on top of metadata. It's knowledge about that. And it's an explicitly available knowledge model most often, so you can reuse it. There are a lot of knowledge graphs around you could reuse already. Metadata is machine processable. That's important because it's standards-based, so you can make links between the different silos. And that's exactly what I want to show you in the next couple of minutes, how that could work. Let me give you a very quick example to show you already something very concrete you can try out later if you want. We've been working quite a while with Health Direct Australia, and they've been facing a big challenge, which is about the integration of a lot of different information sources. They deal with information from over 120 information partners, and all of them provide trustable and high-quality information for the health and healthcare sector. It's very much for the citizens, but also for the professionals. But in any case, those information partners, as a citizen, you always had you were used to search around and look at any of those portals for relevant information. There's still a great variety of category and metadata systems. That wasn't changed, but those different systems, metadata systems, were linked to one central vocabulary hub. So more or less on top of all the information sources, a knowledge graph is now serving as a way to integrate and bring together all the different categorization systems. And at the end, the end users really have a much better interface and ways to access all this different information. So let's take a short look on this application maybe. So that's one of the typical facilities you would expect, of course, from a search engine like that. So you have an autocomplete, you have different names for probably the same thing, but at the end you really have the quality information in place, like in that case for measles. And you see here there's a lot of different information sources integrated, and you have only one categorization system in place, one way to refine the search results. So you can now click on those facets if you want to drill down and so on. So that's the interesting part of the architecture, I believe. If you take a look on that, there's a semantic service which makes sure that the incoming information, in that case it's based around Alfresco, the incoming information is all harmonized with its metadata on top of the different information sources, and that's done by this semantic service. And another option, of course, as soon as you have a standards-based knowledge graph on top of your information sources, you can enrich that by relatively low costs. So one of the next steps at Health Direct Australia now is to link their own knowledge graph by others, with others. So the Australian Health Thesaurus is standards-based, of course, based on RDF and SCOS, and now it's open to enrich that with other information sources with relatively low effort. So that's the other aspect I would like to bring in. Okay, let's now go to Chapter 2, short overview of PoolParty Platform. So what is it all about? It consists of three components mainly. The first one is the PoolParty Thesaurus server. So it helps you to create taxonomies, thesauri, and ontologies. The ontologies I will show you later, they are meant to be used to apply them on top of a simple taxonomy, so you can make a taxonomy more expressive if you want. I will show you an example later. And here that also should show you that, of course, you can maintain more than just one taxonomy with PoolParty Thesaurus server, and if you want, you can link those to each other. So there's a mapping facility, which is exactly what Health Direct Australia, for instance, has been using, but that's a typical approach. You probably don't have one large taxonomy in place, but rather maybe a central hub, something like that, and then more specialized taxonomies. And that's exactly the main idea of linked vocabularies. In any case, the second component, the PoolParty extractor, is doing two things basically. The first one is it analyzes text and extracts entities and terms and phrases from it, and as a side effect, or as maybe the main issue here, is it transforms the text also into a graph-based representation, which is nicely linked to your knowledge graph instantly. So it's enriching your knowledge graph, if you want so. All the information streams which come into the PoolParty server will instantly convert it into RDF and link to your existing knowledge graph. And I will show you an example in a second. By doing that, you are able to do much more complex queries over your information sources if you want, and you can link structured with unstructured text, data. So that's the basic idea. Also with linked data, it's not restricted either to text or to relational databases or something like that. No, it's really a universal, let's say, layer on top of all the different data formats. And the third component, the PoolParty power tagging, that's the integration layer. So you can see here there are a couple of integrations in place, Drupal, SharePoint, Confluence, and one of the main features or functionalities provided by power tagging is a semi-automatic tagging facility on top of a controlled vocabulary, which helps end users later to access the information in a more accurate and precise way. There is a question coming up. By the way, whenever you feel like you would like to place a question, there is this questions widget in GoToMeeting. I might answer them at the very end. But let me see, does PoolParty have a view for this graph structure at the bottom of the PoolParty extractor? So that question is really about the visualization down here. Yes, there is a visualization component in the PoolParty Desaro server, but it doesn't look like that. So that, to be honest, that's something I've created with a drawing program. But what we figured out in recent years is it's really not about the visualization of the network that much, which generates new value of your data. It's really about integrating and providing unified views over dispersed data. So it's not the network visualization that much what really helps you at the end. Okay. Yeah. That's the principal overview. So if you take a look on the same thing from a workflow perspective, there are at least those three roles. In addition, of course, you've got the end user. So you see the taxonomies probably rather works on the Desaro server. So the developer has APIs to access those two services, and the content manager is more using the power tagging dialogues, which are embedded in the CMS mainly. And you can also see there are two learning loops. So the whole system is learning from the incoming information instantly. There is a corpus analysis in place, which makes sure that the knowledge graph is growing in parallel with your content sources. That's an important feature, I believe, that your knowledge graphs are not, let's say, remain in a certain version, and then later, months later, you find out, okay, the content has evolved, the topics have evolved, and the taxonomy doesn't reflect anymore what, let's say, the knowledge workers in your company are talking about, or the news consumers of your news portal would like to see. So PoolParty is very much dedicated to the idea of being a learning system. So that's the summarization of all of that, PoolParty core components. Just important to know there's Desaro server, create and maintain taxonomies. There's extractor, which does as the name already says, extract all the entities, RDFIs the text, and the power tagging is the integration layer. And for instance, with SharePoint, it also provides semantic search. With Confluence, it even goes beyond that. There are recommendation services and so on. Okay, Chapter 3, Better Together, Unstructured and Structured Data. So if you take a look on this picture here, I think that displays a bit what we are what we've been making through in the information management community in recent years. I think the concept-based search was one of the, let's say, biggest breakthroughs. We are still in the middle of that somehow, that it's well understood that it's not about terms, it's really about things. So it's not about strings, it's about things. And that's exactly what concept-based search is addressing. But the next logical step beyond the concept-based search, of course, is the linked database search. So here, those rather, let's say, simple knowledge models, you can see here they are mainly based on SCOS, can be extended by additional technologies, by additional facts and additional structures. And that's possible because of the really fast development we've seen with RDF triple stores in recent years. So there is still the strategy to enrich a document index by taxonomies or information from taxonomies. So actually the index finally ends up in a more or less traditional document-oriented index. That's great, and it goes far beyond what term-based search could offer to you. But with linked database search, it's really, let's say, a true semantic search, because here you access all the data by making use of this explicitly available knowledge graph. And we don't use, in that case, I don't know, Solar, for instance, anymore. We really use linked data, RDF-based graph stores. And we are working together with a couple of those companies which provide highly professional databases in that area. And what we've seen in the last 2 or 3 years was a lot of enterprise features were added, for instance, graph security, and performance was increasing tremendously. So we believe that linked database search is now really ready to be used by enterprises. I want to give you a short example. So that's a very simple, graph-based search, which reminds you, of course, on all what you've seen with concept-based search so far. So there's search facets, there's autocomplete, and so on. So so that's the live version now. I will give you an example. So that's different sources here. So you can see it's in the medical sector here. A couple of different medications are mentioned here. So the data was mainly derived from PubMed in that case. And there's a MASH thesaurus in the background. And here you would see the results. So now you can drill down, of course. So that's all these typical search facilities you probably expect from semantic search. And the great thing here, at least for the technologists of you, is there is no Solar or something like that in between anymore. It's really based on a SPARQL endpoint. And still, quite complex queries like okay, I have to reset, otherwise I don't get anything here. It's of course restricted down to the result set we've got here. So even this, let's say, categorized autocomplete and besides the facets are quite fast. And the advantage of all of that is, as you can see here, the document itself, it's represented as an RDF graph. And the main reason we are running all these through these efforts really is that you can use this graph-based representation of all the different information sources to link those together in an automatic way. And that's exactly what I will show you in a second more sophisticated application what you can do with that on top. So just remember, please, that's not based on a document index anymore. It's really based on a triple store. In that case, it's based on Virtuoso, and it's ready to be used by enterprises. It contains or offers graph security. It offers different connectors to relational databases and stuff like that. So it's really a technology which is ready to be used. So that's the picture, more or less. Here the information comes in. With PoolParty, you can transform all this different information into RDF. Of course, you have to have a knowledge graph in place which more or less tells the system how to transform that, and then you put this or analyzed information together with your taxonomy in a RDF triple store, and with a SPARQL endpoint you can create such applications which contain structured autocomplete, precise search facets, and of course that's the just another representation of topic pages. So you can create dynamic topic pages based on the hierarchies of your taxonomies by this approach as another way to represent the data. And it's fully RDF compatible, and all queries are via SPARQL. So you can later do also federated SPARQL queries if you want. So that's another story, but will come very quickly in the next few months, I guess. Okay, so that was probably rather simple application based on knowledge graphs, and now I'll show you a more complex one. Let's assume there's a business analyst, and this analyst wants to explore medical research trends in relation to regional prosperity. And therefore, I mean, of course, this query is not typically what business people would like to type in, so what we have to have in place is an interface like that. So that's this little demo application, and it contains in the background, actually it consists of 4 linked graphs. One is the mesh graph, once again. Another one is the transformed PubMed input stream. So we analyzed 150,000 documents here. A third one is geonames. Of course, we make use of all the hierarchies in it. And the fourth one is DBpedia. And geonames and DBpedia are connected to each other, so we can find out the Human Development Index per country. And that's one of those filters. So I can now drill down and say, okay, all the countries which have quite a low Human Development Index in contrast to those with a rather high. And maybe I'm more interested in, here we make use of the MASH categories, for instance, rather interested in nervous system diseases. And here you can see the different results and compare them to each other. So on the left-hand side you have brain injuries, meningitis, for instance. On the right-hand side you have stroke, pain, dementia, and so on. So that's, let's say, a business intelligence-like application rather. And I would not say it was impossible in recent years to produce such applications. Of course it wasn't. You were able to integrate data. But the big difference now really is it's much more agile. It can grow with your needs. So you start small and you grow and grow the knowledge graph. It's more or less schema-less. You don't have to design the application from the very beginning and following a very strict path and say, okay, at the end you want to have those kind of queries. If you want systems which can grow dynamically to the needs of your employees, of your customers, of the citizens and so on, then linked data, we strongly believe, is a good solution. Okay, so that's how it looks like in the background. You can see here content was annotated with geonames. Geonames has got a link to DBpedia with a corresponding HDI. There is mesh, and all that together with the SPARQL engine, you're able to produce interfaces like the one I just showed you. Even these pie charts are just one step away from the SPARQL results, so there's nothing in between anymore. So now if you take a look on the overall picture, we have several different sources. We integrate those with different knowledge graphs. They can be linked to each other. So we have more than just one graph in our database. We have classified documents, we have linked taxonomies, we have additional knowledge graphs maybe from the linked data cloud or from other sources. In that case, we've taken DBpedia and geonames, and with a SPARQL interface, we can easily produce an application like that. So that was the PoolParty Semantic Integrator under the hood you've seen right now, and just before the PoolParty Enterprise Server would be sufficient. Okay, so next step, it's now about 30 minutes. So we're about in the middle of the webinar. There is another question. Can you search against sources stored in SharePoint, Confluence, or Hadoop? Absolutely. That's one of the basic ideas. With the power tagging facility, it's possible to integrate all the different platform technologies, because power tagging is mainly based on the extractor. So the extractor can store the annotated documents in a, we call that linked data warehouse, and so that can come from different platforms, and they can all follow the same knowledge, or the extraction rules of the same knowledge graph. So they will be instantly be linked to each other. So if you have in SharePoint a document which talks about a certain location and a certain disease, and also in Confluence maybe, or in another source, wherever it is, they all will be transformed into the same RDF format with the URIs. The URIs are the uniform resource identifiers for everything you have inserted into your knowledge graph, so they will be linked instantly to each other. Also, they probably reside in their own named graphs. That's another dimension you've got. It's not a flat graph you have in a linked data warehouse. It's a multi-layered graph, but still connected to each other, so you can also put provenance information or security information per named graph, and filter out, for instance, all the information a person is not allowed to see. So that's the principal idea here. So you don't have to import them. That was the second question. No, you don't have to import them. It's really very much like a typical, let's say, enterprise search scenario, but the big difference is that you can await or expect more precise results and ways to do more complex queries. Okay, so next chapter is chapter 4. What's new in the latest release of PoolParty? Yeah, before I forget to point you to the possibility to try the software out on your own. Here it is. Just go to our website, please, and you will find very quickly try it menu on top, and you can get an account within 2 or 3 minutes and try it out on your own if you like. Okay, here are the main 5 new main features I would like to say. So first of all, what we've been working on quite a lot is to improve the entity extraction. It's one of the key features, of course, of such a platform. And for instance, one thing we've been working on quite a while was to introduce disambiguation rules. So what is it? I mean, we all know this Java or Jaguar problem that's clear. In reality, it's probably not that complicated because there's not very often a knowledge domain in which a car and a cat will play a very important role. But in many domains, of course, you have a lot of abbreviations, for instance, which could mean the same thing. But in general, also, if you work in the news industry, you might know problems like this one you have in front of you. Brian Johnson could be a baseball player, could be a songwriter or singer. So if we find that somewhere in a news document, how can we figure out that it's Brian Johnson, let's say the singer? And here, of course, we have good preconditions to do so. Because of the knowledge graph, we have quite a lot of context information around every Brian Johnson, if you want. So here you can see that's the football player, that's the singer of AC/DC, and then there is Brian Johnson playing for Boston Red Sox. So that's a good precondition, of course, to figure out which of the Brian Johnsons it could be. And with a disambiguation settings we introduced with PoolParty 5, you can now state very precisely which path in the knowledge graphs should be followed to collect context information around ambiguous terms. So it's not just a direct neighborhood which is being analyzed, it's really the more or less whole graph. So we follow, but you can restrict down and say, okay, just follow certain types of edges in the path in this knowledge graph. So the knowledge graph, just to give you a bit background information here, of course it could be simply cost-based, which is a simple way to express a knowledge graph, but you can extend that by additional properties. For instance, you can say in that case you see only has broader, has narrow, has related, but it could be also is producer of if you have introduced another property to connect to nodes in your graph, and you can exclude that or you can include that in your disambiguation rules. And you can also put a negation there if you want. So you can really say if Brian Johnson is the singer, then it's in no case related to Red Sox, for instance. So you can really state a clear negation. By doing that, you have a very, very high probability to extract the right entity. So that's something very frequently asked, of course, disambiguation rules engine, and that's exactly what PoolParty can now offer to you if you are interested in this feature. Second reason to take a look on PoolParty 5. We've been working again quite a lot on a more and more or deeper and deeper integration with all the content platforms we support with PoolParty. So for instance, with SharePoint, we now have a constant synchronization with the term store. So the power tagging facility, and that was with the earlier version already in place, of course, has always been able to extract entities from SharePoint documents, so you can configure which parts of your document should be analyzed and which extractor should be used and so on. But we frequently asked feature was it should be in sync with the built-in term store. I mean, the term store in SharePoint is not necessarily the right place to maintain taxonomies, but it has quite a lot of features to offer, like autocomplete and so on, to tag stuff manually. So yeah, now it's all in sync, but but nevertheless, still the text analytics of PoolParty helps people to find the right tags, and also the SharePoint search is of course still being enriched, and you can configure that by all the information from the taxonomy, which is maintained in PoolParty, of course. So that's what we've done for SharePoint in this release. Drupal was extended a lot. We have now a semantic connector in place. You can connect all the Drupal modules, and also the semantic search was integrated. We call that Sonar server. So the Sonar server can now be attached as a Drupal module. So that's what you see here, for instance. And with Confluence, so that's how it looks in Confluence. So here the facets, for instance, they are derived from a taxonomy again. You have a similarity search in the Sonar server. You have trends. You have watchdogs and stuff like that. But what's really new is the integration with Confluence blueprints. So blueprints in Confluence help users to work in a structured way on documents. So for instance here, there could be the structure to describe a link, but it could be everything. It could be a medical record. It could be a frequently asked question, whatever. And we can now attach to every field, we can configure that, of course, certain parts of the knowledge graph and say, okay, this field should be make use of a certain part of my taxonomy, and by doing so we can create a very precise faceted search later. And of course, again, there should be the loop back. So if for instance new text was coming in, either new tags by the end users or complete new unstructured information, the loop back should be triggered. New tags can be put in, new entities can be put into the knowledge graph and so on. So that's now available with Confluence based on the blueprints technology provided by Confluence, and it's a very flexible way to create applications you could call semantic records management. Number 3, one of the main ideas to make the taxonomy management efforts as low as possible is to extract candidate terms from all the different sources you have in place. So one of the typical things would be to extract them from a website. And with PoolParty 5 now, you can crawl whole websites. So we added, in addition to 4.x, which was the ancestor of 5, obviously, we've added the crawl website feature, the crawl RSS feed feature, and also very kind of a low-hanging fruit, the crawl DBpedia feature, which means if you, for instance, have created a seed thesaurus from DBpedia, which is a long-term feature in PoolParty, so you can extract very quickly from DBpedia thesauri for virtually any domain, then you can also crawl the corresponding unstructured information around those entities to make use of that for building a reference corpus out of it. So the reference corpus, or text corpus analysis you make on top of those different sources help you, of course, to create a good basis to extract new terms and put a good relevancy score on top of it, but also, of course, to create new a list of candidate terms. So, for instance, I crawled poolparty.biz, and that's the result, as you can see. So you also will find out very quickly what are the most frequently mentioned terms on a website, and if you have already a thesaurus in place when you do so, you can also see which of your concepts and approved terms are frequently used on this website to probably find the gaps in between your controlled vocabulary and the content base. So that was number 3. Number 4, it doesn't sound like a tremendous enhancement, but we believe that look and feel, user experience, and the user interface and all the workflows which should be supported by a high-end knowledge graph management and taxonomy management tool. We believe that's one of the key features. We think that it should be as smooth as possible. It should even make fun, probably. So we really hope that this step was really a key to increase the user experience once again. And I would say try it out on your own and enjoy working with PoolParty. That's the whole idea here. So we spent really a lot of time to bring in all the issues raised by our clients, of course, and let's say a completely new design and refined control elements. Yeah, last but not least, we started with ontology management quite a couple of releases ago, but we were not finished with that until 5.0. I mean, we are still not finished. You can always extend this feature, that's clear. But I think we can now talk about a full-blown ontology management. Why can we say that? Of course, I'm not saying we are covering all the expressivity you would get probably from other ontology management tools, but you would, or what we've seen, you will get what you need in 99% of the cases. So we've tried to understand as well as possible what's really meant by ontology management by most industries. Is it the pharma industry? Is it the vehicle industry and so on? We figured out that what OWL offers is really rarely being used in concrete scenarios. So we really tried to focus simply on that, what's requested by the industry. And so it covers now, of course, all the class and subclass features, domain range restrictions, and so on. What, for instance, we've seen what's not that important are things like disjoint statements between classes and things like that. That's not covered by PoolParty. Here we really recommend to work with another tool and then import this into your semantic database. But with PoolParty, as I've said, you can cover most of the challenges you probably face when you are working on your own ontology. And one of the main ideas here really is that you apply ontologies on cost taxonomies. So maybe we take a very quick look here. You first generate kind of this cost taxonomy. And then in the next step, you, of course, extend and curate that. You have quality checkers with PoolParty and so on. But then you probably want to apply ontologies. You want to extend this cost schema and make use of all the, let's say, nice features an ontology can offer, for instance, to make sure that certain relations are more meaningful and only can be stated between those things where it makes sense. So let's take a look on that. It's easier to explain it on top of an example. So I created a small example which is about the IT industry. And here, that's a simple cost tree. So there are the concept schemes. There are a couple of companies in here. So for instance, software producers And on the other hand side, there are products, for instance, software products, enterprise software products, for instance. And of course, with costs, you can easily say, okay, Adobe is connected to Adobe Photoshop by simply drag and dropping that. So you can say Autodesk company is related to AutoCAD. But what exactly is this relation meaning? And therefore, you can extend this cost schema. So you start with costs, but you can later apply ontologies on your cost tree. And you see that here. So Autodesk is already classified by software producer, and as a automatic assertion, since software producer is a subclass of corporation, and that's again a subclass of organization and thing, it's all classified like that. And since I've stated in my ontology that a corporation or a software producer can have certain relations, like for instance, it can be a producer of a software product, or it can have a certain number of employees, I'm now able to do that in this additional tab, which I can activate. So I can now say Autodesk is a producer of a software like AutoCAD. What I cannot do, of course, is I cannot say Autodesk is a producer of a company like MarkLogic or whatsoever. It's not possible. And I can also say, okay, Autodesk has around, I don't know, 10,000 employees. Of course, I cannot do that with, for instance, software product. Here, I have only the relation is produced by. I don't have a number of employees and so on. So here you can see it's classified differently. So the whole idea really is start as simple as possible and let your knowledge graph grow, attach or apply ontologies later, so your knowledge graph becomes more and more, let's say, intelligent. And later, of course, you can also benefit from that when you do entity extraction and stuff like that. So it really opens up a lot of new opportunities. But what we've seen frequently is don't start with an ontology first and then later populate that in a cumbersome way. A taxonomy is really a nice place to start with. Okay, so there's another question I see. Okay, unfortunately I have to go. Thanks for joining in. And there is also a question if the sound has gone, so I don't think so because we have some quality checks here going on, so I should know that. So probably it's on your side. Sorry about that. But there will be a video on. Okay, so now I come to the end, more or less. What's next? What's the linked data path? Okay, so that's really the outcome of what we've seen frequently. Quite a lot of organizations in the last few years were somehow beginning with the idea to introduce linked data technologies. Some of them succeeded, some of them failed. And this path here should take care or make sure that if you are about to run your own linked data project, make sure not to miss those 8 steps, more or less. And what we've really frequently seen was it has a bit of a learning curve to understand what a knowledge graph is, how to maintain that, and why you should make use of that. So it's really important to build up some capacities, some knowledgeable people in that area, or at least to invest into some resources probably you will get from the market. But it's clear at point number 4, where the development of knowledge models will come around, you have to have already some capacities internally, otherwise it won't work. Linked data is not a magic box you can set up and after a while everything is in place. It's really something which has to be maintained, and that's important to know. I believe it's semi-automatic. It's a supervised learning approach. Yeah, so I think also it's important to understand the strategic dimension of linked data. I believe a couple of industries, like especially pharma industry, has already quite understood why linked data is important for them. So it's a more strategic effort already, not dedicated only to have one, I don't know, a little bit better search engine for one department. That's really something I wouldn't say the effort would be too high if you were just looking for a bit better search engine. It's really about creating an enterprise knowledge graph, to my opinion, and to convince other decision makers, it's really important to define feasible use cases very early. That's number 3. And I think those two are really great points you have to address from the very beginning. The reusability of information, that's something which is really about saving costs. When information is created, it's most often very cost intensive, and why not reuse it wherever possible? But therefore you have to break it down into smaller assets, and you have to make it accessible, and that's this knowledge graph I'm constantly talking about. And that's also the precondition for one of the most central use cases, I believe, which are integrated views on business objects. You could call them landing pages, topic pages, whatever. But that saves really a lot of time later when people have to do research. Is it let's say, a consumer who wants to know more about your products? If they have integrated views on your products, they will better understand what they can do for them. Is it a project or a technical artifact, for instance, in an engineering company? It's always the same. All the information is somehow dispersed, and with a knowledge graph in place is a good chance to integrate this into one single place. Yeah, and sooner or later first projects will be created, and here I think it's important to have those higher prioritized, which also help all the involved people to learn very quickly how this technology works. So it should be a mixture of course, use cases or projects which really are worth their investment, but also, at least for the couple of first projects, it should be something which empowers the people who are involved to understand this technology very fast. And then, of course, don't forget to communicate the strategic dimension of linked data. Otherwise, it will remain probably only a single project, and nobody really will get the idea of it. Yeah, so I think that's it. That's my linked data path, at least. I'm sure there are lots of others, and probably we will have some crossings here or there, some intersections I'd like to discuss with you. Would be great. And the next step could be to log in, dive into your data pools. So that was it. Thanks a lot, and I will look up if there are new questions. There are a couple of those. So I will start with a couple of questions, and then in about 5 minutes, if somebody wants to remain or stay with me, would be great. We can discuss, and I will open up the microphones. So now that's the official end. Thank you very much for being here, and I hope you have received some new inputs for your potential or ongoing linked data project. Bye-bye. Okay, so coming to some of the questions here. Does the web crawler rely on HTML? not necessarily. It's really a web crawler, and PoolParty can digest also other formats. So it could be a PDF, it could be PowerPoint or Office document. So it's of course the linking structure we traverse that relies on HTML, but it could be at the end, it could be ultimately a PDF document that works. Okay, then there was, I hear you fine, thank you. So obviously there was just at one end, unfortunately, a problem. Yes, I will share the slides with the participants on this call. First of all, I think there will be a follow-up email sent out by GoToMeeting automatically. And if you go on slideshare.net and search for Semantic Web Company, this slide deck is already online there, so it's already public. Then there's another question on the semantic integrator. How are the questions constructed? End user friendly or plain SPARQL? Yeah, that's a very interesting question, because of course, yeah, I think we have a strong agreement on that. SPARQL is not meant to be used by end users. That's clear. On the other hand side, SPARQL is really flexible. It can query, of course, in a way with SQL you probably wouldn't like to do. So the interface between let's say, natural language query and SPARQL is one of the, let's say, interesting features here, I guess. To translate that really from a natural language query, any kind of question type into SPARQL, that's a holy grail, I believe. It's not in place yet, as far as I know. Of course, it works nicely if you have a certain domain in place. Let's say, I don't know, private equity. Here you have certain types of questions. You have certain types of things. Which company invests in a certain technology being located in the Silicon Valley? You wouldn't ask how tastes a certain cocktail. I don't know. So if it's restricted to a certain domain, there is a good approach we can take to translate natural language queries into SPARQL. It looks differently to a broader search engine. Let's call it that. Think of Bing, Yahoo, or other search engines on the market. They really have to cover all of those different questions, and it's much harder to translate everything into SPARQL then. So I'd like to discuss that with you. Nadine, if you want to stay in the call, maybe we can find out some interesting next steps. So there was a question also, what is an enterprise knowledge graph and what is a knowledge graph? I interpret that as a more or less in contrast to. So knowledge graph, of course, is a more general approach. It consists, from our perspective, of several taxonomies being enriched by custom schemas, additional information. Everything can be enriched by other relations, other attributes. I just showed you, for instance, a company can have number of employees, can be related to product, and so on. And the knowledge graph, of course, also consists of all the links and relations to existing assets like a document, a video, and so on. So it's really a way to represent a way, first of all, to access all this different information, and second, also it's also a structure which includes all the instance data. And in contrast to let's say a general knowledge graph, an enterprise knowledge graph of course, would be something more specific. It's if the enterprise is working in a certain industry, and of course it wouldn't cover all the facts and all the types of things you probably would expect from a more general knowledge graph. So it goes more into the details. Yeah, and then thank you. Thank you. So thank you to you also back. And then how does PoolParty interact with RDFA, microdata, and schema.org? Also a great question. I start with schema.org. Schema.org is one of the schemas we support. I go back to the server here. So here we have an ontology library we make use of. You can enable ontologies if you like. I just have to click that. So here you can see that's the ontology library on that server. So for instance, we have schema.org. That's one of the ontologies we would like to make use of. You can activate that. And as soon as you've done that, you can create your own custom schemas on top of that, like I did with IT industry. You can add a class. Here I added the class of hardware producers, software producers, and so on. And you can see here it's an autocomplete functionality. I could now add, I don't know, product model to this custom schema, which will be a subclass of product. I could call it my product model ABC, and I can add either product model as a class to my schema, and now I can add my product model as a subclass of the existing one. So it will inherit all the restrictions and attributes and so on which were stated in schema.org. And as soon as we've annotated and classified entities from, for instance, a web document with my product model, you can also state it's an schema.org product model. And of course, you could publish that with RDFA, using RDFA. And later, search engines will make use of that. So that's one way how PoolParty interacts with RDFA and schema.org. Of course, also the other way around, which is not in place yet, that could be a future feature, is to harvest the statements embedded in HTML and make use of them to further enrich a knowledge graph. So that's not in place yet, to be honest. It's the PoolParty extractor mainly makes use of unstructured text. Then the SharePoint integration. How is the metadata already existing, generated in SharePoint 2013, used by the PoolParty taxonomy thesaurus? Also a very good question. That's typically one of the first steps. We would harvest that or export them, make sure that this already existing metadata will be transformed into or integrated into a taxonomy. Maybe you will further elaborate on that. And then later, this taxonomy will be used to produce all the metadata semi-automatically on top. So one thing, of course, which is important to know, we don't use simply terms to annotate SharePoint documents. We rather use the resource identifiers, the URIs. So we have to replace the existing metadata, which are terms in the original SharePoint, with the URI, which have been created by PoolParty automatically. But from that on, the whole system will work smoothly. So that's the typical strategy here. Another question is, during entity extraction, is it possible to insert RDFA microdata into the HTML? Absolutely. I mean that's really up to you if you want to implement that as a potential extension of HTML. It's not an out-of-the-box feature. So the PoolParty extractor is really something which is a very, let's say, generic service, which can be integrated with a CMS in several ways. But you're pointing to one of those really great ideas, I think, how to make use of an entity extractor in a rather, let's say, HTML-oriented scenario. Yeah, so that's it. That's all the questions I've got. Thanks again. Very interesting. It always helps also us to learn a bit more about the interests. And now what I will do now is I will switch on the microphones. Maybe some of you are really still there. Maybe some have already left the computer and still online. So we'll now unmute.
Unmuted.
So Andrew, are you there? Andrew? Arthur, are you there?
Hi, yep.
Hi there.
Sorry,
Is it Arthur or Andrew?
This is Arthur.
Hello, Arthur. How are you?
Oh, fine. I missed a little part of your talk, sorry.
Oh, okay. It will be online, so if you have more time left, you can. Any particular question at the moment? Is there anything you would like to discuss? So a couple of people are still there. Maybe something you want to discuss publicly also?
Well, I guess I would like to see the way the ontology manager works in PoolParty 5, if that's changed. But I expect you've already shown it, so I don't have to do that now.
Yeah. It was quite extended, also by its, let's say, internal way to process the data. So there is a rule engine integrated based on Jena, and it's something I believe will help you quite a lot to produce meaningful statements around your cost concepts. And one of the things which sometimes probably at the very first when you get in touch with this approach is a bit confusing is that everything still remains as cost concept. So if you look at the triples, so for instance Oracle database, it's still as cost concept, but of course it has received additional types. So for instance you can see here it's a schema.org product, for instance, in addition. And that's your own schema here, a software product. So it has multiple types now.
Is there any way to apply the multiple types to the concept schemes, concept schemes themselves, or those are just concept schemes and nothing else?
Yeah, the concept schemes remain concept schemes. So we don't classify them, but you can classify collections. That's also what we've applied. If you want, you can create your own collections and apply types to collections and all the members, of course, automatically.
As I recall, there was a way to apply a type to a concept scheme so that all of the concept scheme had that type, but that was the only thing I recall.
Yeah, but maybe so the idea is you can attach a custom class. So for instance, to a target group. Let's say you've got somebody's typing here. Okay, so for instance here there is target groups as a concept scheme. And you can, so in that case I already applied a custom class. You can...
I think that's a neat picture.
Okay. I have to mute a couple of people. So it can be applied recursively. So you can say, okay, that's org. I take the org ontology of W3C and I say all of that is an organization. And now it's applied recursively to everything underneath. So Google now is an organization. So, and you can do that at every point of the tree. So you can say, okay, those are enterprise customers, and you could put there all the different industries maybe, and then take one of the classes you've defined here from whatever schema you've created. So it's done recursively, but the concept scheme itself is not classified. Only everything which is underneath is everything which is a sub-concept or in this scheme. That's the point.
Yep.
Makes that sense?
Yep.
Okay. Okay. Any other question here? I try to unmute so that all the people rang in. I cannot unmute. So, Bill, are you there?
I am here. I'm just right now I'm using the demo and loading content and trying to extract concepts right now. So
okay.
I did try entering a URL for a PDF. I was the one who asked that question, and I got some kind of error or failure message. Now I've actually loaded up about 11 Word documents, and I'm trying to do the entity extraction. So I don't necessarily have a specific question for you right now.
Okay. Yeah, it's if you start without any taxonomy in place and first with a document analysis, which is a absolute supported process, we really have to point out clearly that with probably 10 documents only, the results won't be that great.
Okay.
So what we usually suggest to our users is really to take care of enough information to create a good basis to calculate relevances from there. So for instance, all the co-currencies and so on you could make use of later, of course, will benefit a lot from enough documents. So one rule of thumb we usually say is it should be around 1,000 pages, something like that.
Okay.
It should also be, it's better to have more but smaller documents. So let's say two PDFs and 500 pages each won't produce the same results as 1,000 single page documents, because one part of our algorithm makes use of the distributedness of terms. And of course we do that per document.
Okay. Great. Well, I'll keep playing around and seeing what I can do with it. I really appreciate the webinar. It's great.
Thank you. Good to hear. Thank you very much.
Hello, this is Radu.
Hello, Rado. Is it you?
Yes, that's me.
Hard to hear you.
Okay, let me switch to my phone. I'll be back.
Cannot hear you very well, unfortunately. Can you speak up a little bit, Rado? Okay. Okay, so I think there are not many other questions anymore. Last check on the questions tab, if anything came in. Not really now. Okay, so thanks again to all of you. It was really nice having you in this webinar, and thanks for all the questions. The slides will be online. There will be a follow-up email with all the information. Also, the video should be online in a couple of hours. So enjoy your day. Bye-bye.
Thank you.
Thank you.
Thank you.